Hello everyone, welcome to solve this nice math Olympiad algebra problem. So here we have k times of square root of k is equals to 8, and we solve this problem for all the values of k. So now we move towards the solution of this problem. Here our target is to remove this square root sign, and in order to remove the square root sign we need to take squaring on both of the sides. So when we apply squaring, this will be written as k times of square root of k, and its whole square is equals to 8 square, because we take squaring on both of the sides. And now we use here the nice square rule. According to this rule, we apply the square separately on both of these two values, and we get k square into square root of k and its whole square is equals to, this is 8 square, and we know that 8 square equals to 64. So further in the next step we have, this is k square times this 2 and this square root are gone, and we get here from here we get k only, and this is equals to 64. So here we multiply k square with k, and we get k cubed is equals to 64. And now we move the term 64 from right hand side to the left hand side, and this will becomes k cubed minus 64, and this whole equation is equals to 0. And now here we rewrite this equation as k cubed minus, this is 64, and we write it as 4 cubed, and this whole equation is equals to 0. So here we use the nice cubic formula to solve this equation. So we know about that, if we have a cubed minus b cubed equals to a minus b times of a square plus ab plus b square. So according to this nice rule, we expand the left hand side of the above equation as this will becomes a minus b. Here the value of a is k minus the value of b is 4 into this is a square, the value of a is k, plus this is ab, the value of a is k and b is 4, plus this b square, so b is 4 square, and this whole equation is equals to 0. And now further in the next step we need more simplifications here, and we get k minus 4 times of this is k square plus 4 times of k, plus this 4 square becomes 16, and this whole equation is equals to 0. And now in the next step we divide this equation into the two cases. The first case is we write k minus 4 is equals to k minus 4 equals to 0, and the second case is we write k square plus 4k plus 16 equals to 0. So we have these two cases, we solve or we find the roots of both of these two cases. So here we have, from this we move minus 4 to the right hand side, and we get the value of k is equals to plus 4. So this is the value of k. And now further in the next step, you see that this is the quadratic equation, and we solve this problem for three methods. You know about that. The first method is factorization method, second one is completing square method, and third one is by applying the quadratic formula. So here we use the quadratic formula to solve this quadratic equation, and for this we write the coefficients of this equation, and its coefficients are a is equals to 1, b is equals to 4, and c is equals to 16. And we state the quadratic formula as k is equals to minus b plus minus square root of b square minus 4 times of ac divided by 2 times of a. So this is the our quadratic formula, and here we substitute all the values of a, b and c, and this will be written as This is minus b. The value of b is minus 4 plus minus square root of b square. B is 4 square minus 4 times of a is 1 and c is 16, and it is divided by 2 times of a, and here our a is equals to 1. And now further in the next step we have k is equals to minus 4 plus minus square root of 4 square, and 4 square becomes 16 minus 4 times of 16, and it is divided by 2 times of 1 is equals to 2. So now in the next step we have k is equals to, this is minus 4 plus minus, here we need to simplify the square root sign, and inside the square root sign we have 16 be the common term, and when we take common 16 we get the remaining values are 1 minus 4, and it is divided by 2. So further in the next step here we need more simplifications, and this will be written as, here we apply the square root on both of these two values, and we get square root of 16 becomes 4 times of square root of 1 minus 4, and 1 minus 4 becomes minus 3, and it is divided by 2. So further in the next step we break this fraction and we apply the we apply these two separately on both of these two values, and this will be written as minus 4 divided by 2 plus minus 4 times of square root of 3, and we know that this when negative sign appears inside the square root sign, this will becomes iota and it is divided by 2. So further we have, this is, these values are cancelled out by each other, and we get, this is 2 times 2 becomes 4. So here we have, this is minus 2 plus minus, this is 2 times 2 becomes 4, and we get 2 times of square root of 3 into iota. So here we get, these are the two complex roots of the given equation. So here finally we have, there are 3 roots of the given equation, in which uh, 2 roots are complex roots and the 1 root are real root. So the final 3 roots are, k1 is equals to minus 2 plus 2 times of square root of 3 into iota, k2 is equals to minus 2 minus 2 times of square root of 3 into iota, and k3 is equals to 4. So these are the 3 roots of the given equation, and this is the final answer. And thank you so much for watching this video. Please subscribe to my channel for more exciting videos.